Okay, we are going to learn how to show work for this question, which says you must show work on graphing paper according to the directions for this problem to earn full credit. Consider the quadratic function f of x equals x squared minus 8x plus 15. In part A, find the vertex using two methods. Show your work demonstrating the two approaches. Number one, convert the function equation to vertex form by completing the square. And method two is to use the vertex formula. So let's begin with vertex form. So vertex form of a quadratic equation or a quadratic function would be f of x equals a times x minus h quantity squared plus k. Now the function has been given to us in standard form, and instead of writing f of x, I'm just going to write y for now because it's a little cleaner and easier to, I think, understand as you're watching this, because we're going to take this and we're going to complete the square. Now, the first thing we're going to do to complete the square is we're going to remove the end of this trinomial, which is the constant term, because right now this trinomial is not a perfect square that can be then what we are trying to do is be able to have a quantity squared with a binomial quantity squared to make it look like vertex form. So right now, we don't have a trinomial that can factor in that way, but we can force it into one that will, and that would be by completing the square. So we are going to take the 15 and move it to the other side of the equal sign. I would do that by subtracting 15 from both sides, and then I would have on the left y minus 15, and then on the right just x squared minus 8x. Now I can complete the square, making that trinomial on the right-hand side into a perfect square trinomial. What I'm going to do is take half of the middle term's coefficient, which is negative 8. Half of negative 8 would be negative 4. And I'm going to be adding negative 4 squared to make this a perfect square trinomial, which then will factor to x minus 4 quantity squared. Now, on the left-hand side, I'm going to have to add that same amount that I just added to the right to keep everything balanced. So being that I just added negative 4 quantity squared, which will come out to be positive 16, as I'm adding 16 to the left side as well, so that everything stays equivalent to the function as we originally received it. So then when I combine negative 15 plus 16, I get on the left y plus 1. And now I'm going to put it back into a form that I can rewrite this as a function or in function form. So y has to be all by itself, and I can simply subtract 1 from each side here. So it zeroes out on the left. Then on the left, now all I have is y, which I can rewrite as f of x. And then my function in vertex form is x minus 4 quantity squared minus 1. So that means the vertex is 4 comma negative 1. Right, so now I've completed step 1 of part A, showing that I've completed the square to rewrite the function in vertex form and then identify the vertex coordinates. So that answer that goes in the answer box there would be the ordered pair 4 comma negative 1, right? But I'm going to go ahead in step 2 and show how I can use the formula, the actual vertex formula, to complete the same, to get to the same answer. Okay, so the vertex formula, so this is step 2 of part A. The vertex formula is negative b over 2a for the h, which is the x-coordinate of the vertex. And then for k, you would just plug whatever you got for x into the function and then simplify it till you get the number. So let's start with writing down the function again. Y equals, well, I guess I'll keep it in function form for now. F of x in standard form, given as it was, x squared minus 8x plus 15. So that a is the coefficient of x squared, b is the coefficient of x, and c is the constant, 15. Okay, so now using vertex formula, I'm going to come up with the h, or the x coordinate of the vertex, which negative b over 2a. I'm going to plug in negative 8 into the top and 1 into the bottom for a. Then I've got a double negative in the top so that I get positive 8 in the top, and 2 times 1 in the bottom is 2, and that simplifies to 4. So notice that I just got 4, and that's the same answer I got when I did it showing vertex form in part 1A, part A, step 1. And now I can find k by plugging that into the function. So I'm going to plug 4 into the function as it was given, x squared minus 8x plus 15. So I'm just taking that value of 4 that I found for h and plugging it in so that I get 4 squared is 16. Negative 8 times 4 is negative 32. And then 15. So combining the positive 16 and the negative 32, I get negative 16. And then negative 16 plus 15 leaves negative 1, which was the y-coordinate of my vertex that I found in the previous part. So now I have completed part A of this. Now I can go on to answer the next question that asks for the equation of the line of symmetry, which is always going to be x equals, because it's a vertical line, x equals a number, and the line of symmetry always goes straight through the vertex, so it'll have to be x equals 4. All right, now part B, write out the steps to find the y-intercept and the x-intercept, if any. Graph the function on the paper beneath your written work. Be sure to label each intercept and the vertex with the point coordinates. Okay, so I'm going to start by finding the y-intercept. So the y-intercept. So to find the y-intercept, recall that when you're on the y-axis, your x has to be 0. And actually, there's not a lot of work to do with this one if you realize that when you plug 0 into the function in standard form, it's going to cancel out all the terms except for the constant. And so actually the vertical intercept, or the y-intercept, is 0, 15, since 15 is the constant in the function as it was given in standard form. So just to show you that, if I replace f of x with y, and then I plug in 0 for x, and I have 0 squared minus 8 times 0 plus 15, then of course these terms cancel off to 0, and then I just have the 15. Okay, so that part's pretty easy. Next, I want to start finding the x-intercepts. So if there are any, because we can have a situation where there are no real number intercepts. And whenever you're finding an x-intercept, you have some x value, and then the y value always has to be 0. So what we can do is we can replace f of x or y with 0 in the function, and then solve for x. So we're going to solve for x now. We could use the quadratic formula, or we can try factoring it. Sometimes that's faster, especially with a lead coefficient of 1. That makes it pretty likely that we might be able to factor it, or at least easy if it is factorable. Looking at 15, I can get 15 by doing 3 times 5. I see that it's a positive 15, so I know the two signs in each of the binomials will have to be the same sign. And looking at the middle term's sign, it's a negative, so I know they would have to both be negative. Now that I've chosen what I think the factors are, it's always a good idea to quickly check it. You could either FOIL the whole thing out, or sometimes just doing a check on the two inner parts. The negative 3 times x gives negative 3x. Sometimes we call this little smile big smile, where you're just checking the outers and the inners and how those would come together to give us negative 8x like the middle term has there. So feeling pretty confident that that is the correct factorization. And since it's set equal to 0, and anytime you're multiplying two things that give you a product of 0, you know at least one of them had to be 0. And that's why we can set x minus 3 equal to 0 and solve to get x equals 3. And same thing with x minus 5 and solving to get x equals 5. So those are the two x-intercept coordinates. So I would put 3 comma 0 and 5 comma 0 in for the x-intercepts on that second answer, in that second answer box. Now the only thing I have not done yet as far as showing my work is to graph the quadratic function. So being that it's on graphing paper makes it convenient. So I'm going to go ahead and set up my axes, and my vertex is at -4 comma -1. So I'm sorry, +4 comma -1. So I'm going to make my vertex over my y, I don't know why I just said my vertex, my y-axis farther over to the left a bit. And I think this is going to be a happy parabola. Oh yeah, it's got a lead coefficient of 1, so this thing is going to be opening upward. So the vertex will actually be the minimum. Okay, so when I see that positive lead coefficient, I knew it would be a happy parabola, and that makes the vertex the minimum or the lowest point. Minimum. So that's how I'm kind of choosing where I want to put my axes, just so that I can make sure that I have enough room to graph this. All right, so my vertex at 4, let's get some green for this, I think. It's a good color to do here. So at x equals 4 and y equals -1 is our vertex. And then we found that the y-intercept, which was at +15. Now, actually, I guess I'm going to need to come down even more. I didn't even think about how high up that vertical intercept point was. So what I'm going to do actually is I'm going to do half steps on this just so I have plenty of room. So I'm going to call this 1, 2, 3, 4. Okay, so this will be 4 for my vertex, and this will be -1 here. So I'm just going halfway in between each grid line to count my units, kind of scale this thing down and make it more manageable. And so my vertex is going to be right there, about halfway. And now I can count to 15. So if I go 2, 4, 6, 8, 10, 12, 14, 16, then 15 is going to be right in the middle there, right? So that's where I'm going to put my y-intercept right here. And so I can also put my x-intercepts. So I had one at an x value of 3 and one at an x value of 5. So I should have one right here at 3 and one right here at 5. So that gives me a good, just those points are going to be enough to give a good picture, as nice as I can draw it. And then I could, since I know the axis of symmetry going through this grid line right here, right, and it's symmetric. So to get to 15, I had to go 2 units to the left to get to that 15 on the y-axis from the axis of symmetry. So I can stay at that height and go 2 over to get a symmetric point there, symmetric across that axis of symmetry to give a better looking representation of how the graph should look. Okay, so there we go. We're all set now.